All right, so we left some room up here because I want you to take some notes so that we can actually do these problems in a moment. So up at the top, add some problems in. So the first problem I want you to do is I want to take the square root of x squared. So actually don't do that one yet. Let's do a number first. So let's do the square root of 9. If you don't know that, you have bigger issues. So what do we all know the square root of 9 is? 3. So we know that. So here's what's happening here in terms of how this is going to work when we're dealing with variables. So notice how I deliberately left a little space in here. What I have, the reason this is giving us a 3, do we all agree that 9 is really 3 squared? All right. What we want to understand is a square root. So this guy right here, this square root, and a square, those are opposites of each other. They cancel each other out. So if I ever take the square root of a perfect square, they cancel. And notice how the only thing I get left with is the base, whatever the number was raised to that second power. Okay? Does that make sense? The other way to approach this, and this is going to be sort of how we want to talk about it with our variables, put a square root of 9 again. And again, we all know that that's a 3. So we can go ahead and say that's a 3. But what we have underneath here is a 3 times a 3. All right. Well, if this is a square root, the idea of a square, do we all agree a square implies a power of 2? All right. That's what square means, a power of 2. So if I look in here, how many sets of 2 do I have in here? Do you see how the 3 has a friend? There's 2 3s in there. How many sets of 3s do we have in there? How many sets of 2 do we have? Just 1, right? So that's why we just get a 3 for our final answer. Okay. One more with a number. So add a third one. Let's say I ask you the square root of 81. Isn't that really? So we all know that's 9. So we can go ahead and say that that's a 9. The reason we get a 9 right there is because that is a 9 squared. And then what we've talked about again is that the square root cancels out the power of 2. And what you're left with is the number that's raised to that power of 2, which is just a 9. All right. All right. We all agree with that. That's old. That's what we did yesterday. So now let's say I give you a power. So let's say I gave you x squared. Square root of x squared. If you understand what we just did, what I just told you is don't squares or square roots, don't those cancel out squares. So if the yellow square root cancels out the blue squared, what is going to be the only thing left over? Hannah, x. So the square root of x squared is just x. That's it. All right. So let's go number 5. Let's say I gave you x to the 6th, and I want the square root of that. Now we have a square root, but we have a power of 6. So what I'm going to do in the next step here is I want to go ahead and create that squared. And then this is what we did a few days ago. What power do I need to have right here so that I could square it and ultimately get the 6 that I started with? What would that be? X to the what? Somebody said it. Brandon? Yeah, good. So x cubed. Because wouldn't x cubed squared give us that x to the 6th? So what should happen, same as the first 4, doesn't the square root, so that blue square root, doesn't that cancel out our squared? That would then mean, what do we have left over? X cubed, because that's what's underneath that squared term. Okay. Another way to approach this, let's say I have x to the 6 and we want to simplify this. Doesn't that mean I have 6 x's underneath? So write out 6 of those bad boys. And then we want, again, the square root. So since this is a square root implies 2. All right. So what that means is, notice how I have a set of 2 right here. So they each have a friend to hang out with, right? They're buddies. Don't I have another set of 2 right here? All right, they're our buddies. And then don't we have another set of 2 right here? So how many nice sets of 2 do we have total? 3. So we could then say that's why we get an x to the 3. Because once you have a friend, you can come out. So that comes out. This guy has a friend, so he comes out. This set comes out. So we had 3 sets of 2 that we could pull out from our radical. All right. So you have to have a friend to come out. All right. So Maria might have a problem. Right. So she's going to have a hard time. Just kidding, Maria. Okay. I'm just kidding. Obviously. All right. Let's say I gave you x to the, let's not do that many. I don't want to write that many. Let's do x to the 7th then. All right. So let's say we do an x to the 7th. Actually, I lied. Don't do that one just yet. Let's do an x to the 8th. Get the general rule down first. So there are 2 options. One of them is to do what I did first, which is understand if I want the square and the square root to cancel, what would the x need to be raised to in order to create an x to the 8th power of 4? Good. So then the square root cancels out this squared, and wouldn't we just be left with that x to the 4th then? All right. Or if I went this route and I write 8 x's, think about how many sets of 2 friends that we have. So here's one set. Here is a second set, a third set. Notice, not coincidentally, we have 4 sets of friends, so we can pull out x to the 4th. All right, following that? Okay, if we don't want to have to rewrite every time, notice what has just happened with these handful of questions. When I gave you x squared, don't we get x to the 1st power? When I did the square root of x to the 6th, don't we get an x cubed? When I gave you an x to the 8th, don't we get an x to the 4th? So isn't there some little shortcut? So don't say it, but see if we understand. Let's say I gave you a big one like x to the 50th, and we don't want to write out 50 of those and circle all of them. See if you're understanding sort of what is our little shortcut that we can just say this right away. Don't say it. So have a thought. You can write it down if you think your thought is correct. But we should be able to do that really quickly. All right. Okay. And Amarian, what would you say? Good. And how'd you get that? By? Good. Since it was a square root, can't we really just divide all those exponents by 2? And that's going to give us the answer without having to do all that work. Okay. However, what if, so now I want to give you this one. What if I gave you, and then we'll jump to the bottom here. What if I gave you x to the 11th? See what you think about that one. And don't give me a fraction power either, or a decimal. Hopefully I can fit 11 of these in here. Yeah, kind of. All right. So kind of see what your thought is here, and then see if it meshes with what I'm going to do. So we have one set of friends here. So this is Amarian and Diana. All right. So they're buddies. They get to leave. They can go out. All right. Here's Henry and Catherine. Catherine loves sitting next to Henry. So they're going to go out. All right. Right, Catherine? Of course. This is Angelina and Kat. They're buddies. They're going to go out of the room. All right.
Okay.
This is who we got here. Riley and Hannah. They're going to hang out. They get to go out. All right. No. This is Sage and me, because we're buddies. We email each other when we're absent. All right. So we're going to go out. So.
That's me.
No. Well, okay. And here's Jackson. Does Jackson have a friend to go out of the room with? No, you got to stick, Jackson. You got to stay. However, how many people are now outside of the room because they had a buddy to leave with? 5, right? All of these sets of 2s get to leave. There were 5 of them. But then poor Jackson is stuck learning the math that he says he's never going to ever use math in his life. And he's stuck in here. Okay. So this is our answer because we have 5 complete sets, but we'd still have the one random one left over. So let's say we don't want to write them all out, which you certainly could. And we go with what Amarian said, and he wants to divide. So go to the 11. Couldn't I divide that by 2? Wouldn't that give me 5 complete sets, right? So I still get this 5 that's out in front, but that would account for how many of the 11? Like it'd account for 10 of them, right? 2 would go into 10 5 times. So wouldn't the 11th one be left over? And that's the one that we've got to leave inside. Okay. Follow that kind of. Okay. So one more, then we're going to do all these problems at the beginning. So hopefully you got a little room because I'm starting to have to add up to the top of the page. So last one, and then we'll do the ones where I actually have space for you to work on it. So now just do one more. Do an x to the 17th and see what you think here. Okay. No. All right. So it's like we have 17 people and we're pairing off. How many and however many pairs we get, we can pull out of the radical. So how many sets can we get? Good. We can get 8 of them, and that would take out how many people total? It's actually 16. So wouldn't we still have the 17th one left over inside? All right. So that's how we do it if it doesn't work out nicely. Okay. All right. So now let's put that together with what we did yesterday. So now let's go to the ones where I actually left you some room to work, because now we have numbers in here. So the way we want to approach these, I would recommend doing these separately. So do the 32 normally. So we're going to need to come up with nice perfect squares to get 32. And then we'll rewrite the variables as their own little problem. So 32, these are square roots, right? There's no little index number here. It's implied there's a 2. So perfect squares. So 1 is a perfect square. 4 is a perfect square. 9, 16, 25, 36. But once we get bigger than 32, kind of pointless to use that one. So which of these perfect squares, ideally the biggest one, is going to go into 32 evenly? 16. And then 16 times what will give you the 32? 2. So that's what you did over and over last night for homework. For square roots, we want a perfect square, and we want the biggest one that we can get. So now we go ahead and start this. So the square root of 16, we all know that to be a 4. And again, that was our homework last night, so we should have a pretty good handle on how to do that. And then the root 2 is going to be left over. Notice I left a little room in here just because we're going to have to put the variables out there as well. So now go to your x to the 4th and tell me how many sets of 2 get put out in front and how many, if any, would be left over. So do this x to the 4th. We've actually already done an x to the 4th, so you can cheat and find that problem again. All right, so however you're going to do it, if we're going to start talking kind of Amarian, he said he's going to divide. So does 2 go into the 4 evenly? Yeah, so those are sets of 2, and that would be 2 sets of 2. Would we have any people left over if there were 4? No. All right, so there are no x's remaining underneath the radical. If I do my 7, how many complete sets of 2 can we get out of 7? 3. So those sets of 3 get to leave the radical. Are there any y's left over? Yeah, there's still the 1 y left over. So he's still inside the radical. All right, and then our z's, hopefully I left enough room in here. How many sets of 2 can we get out of 9? Good. 4. Are there any z's left over? Yeah, because that would only be 8 of the z's. We would have had 9. So there's, oops, let me put my z in first. There's 1 z remaining. All right, and then that's our answer. So numbers, same thing. Variables are kind of that new little thing we did a bunch of at the top. Okay, good with that. All right, so go to number 2. The same thought process. The 192 you're going to do like you did your homework last night. And then the variables are what we did at the top of the paper. So 192, we may want to extend our list a little bit. 7 squared is 49. 6 squared or 8 squared is 64. 9 squared is 81. 100 probably wouldn't do us any good, but that's kind of where we would want to start. And again, Mr. Kubowitz mentioned it yesterday, we probably want to work our way upward so that we find the biggest one first, and then we don't have to worry about breaking it down any further. So see if you can do that. Start doing divide by 100, divide by 81, divide by 64 until we get one that's going to work. Riley has her calculator today, so she can punch away. Did you find it yet? You did it? It's what? You just started. Sorry, I didn't mean to rush you.
So, it's okay. I'm just Maria.
Maria looked up a minute ago as if she had it, so I think she actually does have it, right, Maria? No, maybe not. Oh, she does. Okay, what was it, Maria? We'll let Riley off the hook here.
64 and 3.
Good. So if I did 192, just divide by 81, then divide by 64. Just divide until we find one that goes in evenly, and it would have been 64, and it would have gone in 3 times. Like you would have done yesterday, the square root of 64, we know that's an 8. The square root of 3, we can't do anything with. So that was pretty much the homework last night. All right, you would just write that as 8 root 3. Today we have the variables to deal with. So we've talked about either finding sets of 2 or just dividing by 2. So it's effectively the same. If I want to figure out how many sets of 2 I can get out of 3, doesn't that give us 1? Would there be any x's left over? Yeah, there's 1 left over. Because I had 3, I only pulled out 1, so we would have an x to the first. If I had 8 people, how many complete sets of 2 can we remove? 4. And would there be any remaining? No. All right, so there are no y's left underneath the radical. And then the z's, if I just have one person in a room, how many sets of 2 can we get out of that? None. So you can't pull out any z's. That's just going to remain inside as a z. So sometimes we can't pull anything out. Okay.
So if you have to bring this to the first.
You don't have to put that, no. It's implied that's a 1 if you don't put it. Okay. All right, so now, all right, I'm going to ask you to add one more just so we don't jump right into this one. So right underneath number 3, put it right above this one where it says, now you try. Let's say I gave an x to the 8th. However, I now want this to be a cubed root. So now let's write out 8 x's. 1, 2, 3, 4, 5, 6, 7, and 8. Now in order to leave, now you got to, some of us need to branch out a little bit. You need to make friends with a third person. Okay. So now Riley and Hannah bring in Sage. So now they get to leave. So that's a set of 3. You like Sage enough to do that? She's a little, okay. She can be a little much, but that's nice of you guys. All right. And then here, Henry, Catherine, they bring in Elias. Because Elias is a good guy. He's quiet over there. Doesn't cause any problems. So now that's a set of 3 that gets to leave. Is there another set of 3 that we can get with what's left over? No. So what we would now write, if I want a cubed root, we're now looking for sets of 3. How many sets of 3 x's did I get to pull out? 2. So I'm going to put an x squared out in front. How many x's remained? 2. So underneath, we have an x squared. Amari, instead of the last one, we would divide. Let's see if that would kind of work as well, if we don't want to have to write all of these out. If I had taken this 8, but now I want sets of 3, if I divide that by 3, how many complete times will 3 go into an 8? 2 times, right? And that would get you to 6. So that's why we have 2 of them out in front. But if that gets us to 6 and I had 8, how many are going to remain? 2. So that would give us how many remain. Okay, right. So go to number 3 and let's see if we can now handle that. Cubed roots. Again, a little trickier. So that's why I'm glad we asked about some of those right here on the homework before we collected this. Because now these are a little newer in your minds here. So our perfect cubes, 1 cubed is a 1. But again, we'll never really use that one. That wouldn't do us any good. 8 is a perfect cubed because that's 2 cubed. 27 is a perfect cubed because that's 3 cubes. 64 is a perfect cube because that's 4 cubed. No need to go any bigger because the next one would be bigger than the number we're trying to divide into. So let's just try it. If I did 81 and I took the 81, divided it by 64, so this is the process you'd be doing on the calculator. 81 divided by 64, does that go in nice and evenly? No. So then we scratch that off of our list. We know that's not the number we're going to use. And then we go to the 27. So I'm going to do 81. I'm going to divide that by the next perfect cube of 27. Does that go in nice and evenly? Yeah, that's our guy then. So we're going to rewrite this as a cube root of 27 times the cube root of 3. And then all the variables, we're just going to rewrite right now, understanding though we want now 3 people. Bless you. If I then ask you, what is the cubed root of 27? That means we're going to this perfect cubed and identifying what we cubed to get a 27. So didn't we cube a 3 to get a 27? So the cubed root of 27, you would say, is 3. The cubed root of 3 we can't do anything with, so you're going to leave it underneath the radical, but then we need a little space to do our variables. All right, so x's first. If I have 5 x's, how many complete sets of 3 could I get if there were 5 people or 5 x's? 1 complete set. So that's why we're going to pull out an x to the 1. We get 1 complete set of 3. How many would that leave behind? 2. So we would have an x squared underneath left over. If we then go to our y's, if I have 9 people or 9 y's, how many complete sets of y's could I pull out? 3, right? How many y's would remain? None, right? Because it's perfect. 3 sets of 3 take care of the 9 that we had overall. And then last but not least, if we go to the z squareds, how many complete sets of 3 could we get out of 2 people? None. So you can't pull any out. They both have to stay inside until they make friends with another z. Okay? Okay, last one of these that we're doing together. 54. Think of some cube roots. Again, here's your cube roots over here. So I already have them listed, and we don't really want to explore any more because 54. And then we'll deal with our variables separately. 64 is too big. That's why we're not worried about that one. 1 would never consider. So we're really looking at 8 and 27. Those are our only perfect cubes that would make sense here. And we want to start with the biggest one. So does 27 go evenly into a 54? Yeah, it does. So that's nice. And it goes in how many times? Twice. 27 times 2 will give you the 54. So same thing. If I ask you what is the cubed root of 27, you're going to go to the 27, identify what we cubed to get that, and that has to be a 3. And then the cubed root of 2, can't do anything with it. Do your variable. See if we got the hang of this now. So do the x, do the y, do the z. Okay, it's a cubed root. That means we want sets of 3. So out of 12, Amarian, how many complete sets of 3 could we make from 12? 4. And are there any people left over? No. So that's perfect. If I go to my y's, Maria, how many complete sets of 3 could I get out of 4? How many times will? Yeah, just 1. And then how many y's would be left over? Good. So then we have one y remaining underneath. If I go to my 7, again, it's a cubed root. That's why we're dividing by 3. We need sets of 3. Haley, how many sets of 3 could we get out of 7 people? 2. So that's going to be a z to the 2. And are there any z's left over? What's that? Good. There would be the 1 z left over. All right. All right. Get the hang of this a little bit. What I want you to do real quick, and then we'll come around and do these. Do 1 and 2 on the bottom. 1's a cubed root, 1's a square root. Show us that we kind of are understanding this a little bit. And if not, now would be a really good time to talk to one of us, and we can try to explain it to you while we're next to you. Cubed roots mean we need sets of 3. Square roots mean we need sets of 2. All right, so know what the index number is there. Okay, here your perfect cubes are on the sheet from yesterday. Just as a heads up, they're on those notes. But here's also the numbers you consider. This is a perfect cubed. These should be the only numbers we're trying to divide into those. And we want to start at the bottom and work our way up. So we get the biggest one right away. That's the set. So that's the 3 friends. So there's one set of is that one's 3. So then if I have 8 people, and we're going to need sets of 3. How many sets of 3 do we have 8 people?
Cat, just don't find out.
Here's one set of 3. Another set of 3. So 2 sets of 3. So you have square cube.
What?
3
You
people.
just slapped me.
One set of 3.
This is supposed to be pianist.
So that's what you see here. How many
Like a
people?
what?
So there's 3 things.
This shutter.
And we need to set up. Whatever you're
It's a compliment. It's a compliment. Okay, sorry, what you saying?
Sort of is. So there's no index number. It's a square root. So these are all. It's a cube root. You're gonna go 3.
Robin. No. You're not even Batman. Shut up.
You whatever I want.
Who broke your heart? Who broke your heart? You break the mirror? Why the mirror? It's like.
Okay, no homework. Bring that tomorrow. We'll see how you did on those couple. Make sure you did them right. Good.
Well said. So 3 cubed is 125. Look at my list. See the 125? Then it's 5. So this is 5. You also have to do it every day.
No, we're 50 people.
It's not easy stuff. There's a lot going on there. Bye, Catherine. Thanks, Maria. That's why you have friends, right? Yeah. So kind. Bye, Riley. Thank you too.
Yes, just make sure you get the number.
Well, this is Thursday intervention, so I can study for the test result.
Yeah, I'll bring your old test there. You can look it over. Yep, that'll work. Did you sign up for both days then? Okay.
Well,
All right, sounds good.
Can you email me? You X'd out already?
Oh wait. What do I have up there? I did. Damn it. This is the homework. Right. Yeah, this is the homework. Shit.
I'll just print a copy. Just write it down. Just copy that.
Yeah, sorry. Damn it.
It's fine.
Yeah, sorry.